and welcome to section 1.2. We're going to look at square roots of very big and very small numbers, and we're going to figure out how to do them without a calculator, believe it or not. But before we do that, I'm going to finish off what we were going to do last day, but the video was too long. We're going to look at cube roots and higher order roots. So last time we looked at square roots. I just want to remind you of one thing. When we had our square root, something like this, the square root of 9, we had some words for these things. This symbol right here is called the radical sign, and there's also a couple other words, the surd, the radix. The number inside here was called the radicand, and there's something else I didn't do, but I better do today. This number right here, that little number right there, that's called the index. What? You're saying, what are you talking about, Mr. Watch? I don't see a number there. Well, believe it or not, there's an invisible little number there. There is an invisible number 2 right up here. Okay? If it's a square root, you don't need to put the 2. You can, but you don't need to. And the reason there's a 2 there when it's square root is because, remember, what you're looking for when you're doing the square root, you're looking for a number that multiplies by itself 2 times, so a number times the same number, so 2 of them, and it equals 9. So in this case it would be 3 times 3, wouldn't it? So the answer is 3. So there is a 2 there. You don't have to put it, but for every other root, whether it's a cube root or a fourth root or whatever, you have to put the number there. So in this question right here, you can see there's an index of 3. That's what makes it a cube root. And what does that mean? It means you're looking for a number that multiplies by itself 3 times to get 27. So I think I wrote that down for you here. Yeah, you're looking for a number that multiplies by itself 3 times to equal the radicand. Now that's just for cube roots, not for the higher order ones, but for the cube root. You're looking for a number, in this case, that multiplies by itself 3 times. So we need to put the same number in all 3 spots here, and we have to get 27. Now I'm going to give you a hint. When you're looking at cube roots and fourth roots and fifth roots, the numbers are going to be small. The answers are going to be small. I mean, look at, even if you thought the answer was 5, 5 times 5 is 25. Oh, we're almost there already. Times 5, it's going to be way too big. So it's smaller than 5. You know what it is? It's 3. 3 times 3 is 9, and 9 times 3 is 27. So the answer here is 3. And if you want, because 3 times 3 times 3 is 27. Okay? All right. Now, actually, you know what? I'm going to skip this one. Let me go to this one here. If you have a 4, an index of 4, it's called a fourth root. And what that means is you're looking for a number that multiplies by itself 4 times. So a number times itself, times itself, times itself, and it has to equal 16. Now, a lot of people, when they see this question, they see a 4, they see a 16, they go 16 divided by 4 is 4. Is that the answer? Is the answer 4? No way, it couldn't possibly be. I mean, look, you have to be able to put 4 in all these spots. 4 times 4 is 16, but you're already at 16. If you multiply by 2 more 4s, it's going to be way too big. So 4 is too big. Any idea what it's going to be? It's going to be 2. 2 times 2 is 4, times another 2 is 8, and 8 times 2 is 16. So the answer is 2. And again, if you want, if it helps you understand it, because 2 times 2 times 2 times 2 equals 16. Okay, now back to this one. The cube root of -1. Now, all you good students out there who learned what you were supposed to learn last time in last class, you're probably saying to yourself, well, this question's easy. You can't take the cube root of a negative number. I've got bad news for you. You can take the cube root of a negative number. You can't take the square root of a negative number. That's what we learned last time. If we were looking for the square root of -16, you'd have to say, empty set, it's not possible. But you can take the cube root of a negative number. Now, why would that be? Well, in this question right here, we're looking for a number that multiplies by itself 3 times, and you get -1. Well, look, if they're all positive, you'd have a positive times a positive times a positive, which equals a positive. So that's not going to work. But what if they're all negative? Let's see what happens if they're all negative. A negative times a negative is a positive. And then a positive times a negative is a negative. It works. You can actually do this. So what's our answer? It's -1. -1 times -1 is +1, and +1 times -1 is -1. We have our answer. It's -1. So do you see the difference between the square roots and the cube roots? Basically, if you have a 2 as your index, or in fact, if you have any even index, then you can't take the root of a negative number, whether it's a square root or a fourth root or a sixth root, you can't do it. But if it's an odd one, like this 3 here is odd, then you can do it. So if it was a cube root, you can do it. You can take the cube root of a negative number. If it was a fifth root, you could do the fifth root of a negative number. And basically the reason is because when you multiply an odd number of negatives, you get a negative answer. Alright, so that was what I wanted to finish up from last day. Let's go to today's work. We're going to look at how to take the square root of big numbers. Look at these questions down here. Square root of 250,000. Square root of, oh my gosh, what number is this? 3,600,000,000, I think? Wow, sure wish we could use a calculator for this. No, we're going to do it without a calculator. So the first thing I want to do is just figure out what's 400 times 400. This is one way we can get perfect squares, right? Is to multiply a number by itself. So if you multiply 400 times 400, maybe I'll do it like this. 400 times 400. Remember how to multiply like that? You start with this 0 and you multiply everything by 0. Well, that's going to just give you 0. Now, before we do the next line, you have to put down a 0. Now we're multiplying this 0 here by everything up top, so you're going to get all zeros again. Now you have to put down 2 zeros, and now you multiply everything by 4. 4 times 0 is 0, 4 times 0 is 0, 4 times 4 is 16, and we add 0, add 0, add here 0, add here 0, 6, 1. Now, whether you understood what I did here or not, it's not really that important. What I want you to do, though, is to look at the answer. It's 160000. Okay, I have a question for you. How do you think we could have gotten the 16 without doing all this nonsense? If we knew the question was 400 times 400, how could we have gotten the 16? We could have just done this 4 times this 4, and that would have gotten us the 16. Okay, how about these 4 zeros, the 1, 2, 3, 4? How could we have gotten those? Well, there's 2 zeros here and 2 zeros here, so we put them together, we end up with 4 zeros. That's how it worked. So same with this one. You could start just by multiplying the 1 and the 1 together. So 1 and 1 is 1. And then there's 3 zeros here and 3 zeros here. So you add them together, you're going to get 6 zeros. So that is the answer. Now, what if we were doing the opposite? What if I was starting with this question here, the 1 million, and I wanted to take the square root of it? Can you tell me how we could go back? I mean, obviously, since if we're taking the square root of 1 million, we're looking for a number that multiplies by itself to give a million. Here's your answer right here, 1,000. Obviously, our answer would be 1,000. How could we go from here to that? Well, let's take a look at the zeros first. How many zeros are there? 3. How many did we have in our Radican? 6. How do we go from 6 to 3? We cut them in half. You're going to cut those zeros in half. How do we end up with the 1 here? Well, we had this 1. Maybe it's not a good example. It looks like maybe it just stays the same. All right, let's go back to this one. Maybe this one will help. So let's look at the square root of 160,000. Again, we already know what the answer is because we're looking for a number that multiplies by itself to give 160,000, and we already figured that out. Or we already see that's what it is right there. It's 400. So again, let's start with the zeros. You had 2 zeros, and in the Radican there was 4. So how do you end up with 2? Half as many zeros. Same with this, half as many zeros. Okay, now let's look at the non-zero part. We had 16 here and then 4 there. How do we go from 16 to 4? Square root, my friends. You're going to take the square root. Same here. How do we go from 1 to 1? It didn't just stay the same. We actually took the square root of 1, and that stays at 1 there. So here's your rules right here. What you're going to do is take the square root of the non-zero numbers, right? Just ignore all the zeros. For example, if you're doing this question right here, 250,000, ignore all the zeros and take the square root of what's left over. And then your answer is going to have half as many zeros as the Radican. So we can whip through a whole bunch of these now. If we're looking at this one right here, we start by just looking at the non-zero numbers. That right there, the 25. So we're looking for the square root of 25. What number multiplies by itself to give 25? 5. How many zeros do we have here? We have 4 zeros. So we have to take half as many. How many zeros are going to be in our answer? 2 zeros. That's our answer, 500. Not bad, right? Ignore all the zeros, and here's what's left over. You're going to take the square root of that. What's the square root of 36? What multiplies by itself to get 36? 6. How many zeros do we have here? 1, 2, 3, 4, 5, 6, 7, 8 zeros. But our rule says we're going to have half as many. Half of 8 is 4. 1, 2, 3, 4. We did it. Don't need a calculator. All right, let's look at the next one. We have 49 here, which is good. So we're going to take the square root of 49. Number that multiplies by itself to give 49 is 7. And then we have 3 zeros here. And we have to do half as many? What? Half of 3? What are we going to do? Like 1.5 zeros or something? It doesn't make sense. You cannot do this, okay? In this case, if you don't have an even number of zeros, you're going to need a calculator. We can't do this one in our head. You have to have those even number of zeros. So let's try this one here. You start with the non-zero number right there, and you take the square root of it. Well, the square root of 1 is 1. How many zeros do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 zeros, but we're going to have half as many. So there's going to be 5. 1, 2, 3, 4, 5. Next one. Okay, we have 4 zeros, so that's going to be good. We're going to cut those in half, right? So we're going to have 2 zeros in our answer. And we've got to take the square root of this. What? Square root of 5? That's not a perfect square. How do we do this one? I'm afraid it's another one where you need a calculator. If it doesn't work, it doesn't work, and you just can't do it. But for these other ones, you're able to do it in your head if you have a perfect square for the non-zero part and an even number of zeros. All right, here's a bonus one. Don't need to know this year, but what the heck? Some of you are eager to learn harder stuff, I'm sure. So this one's a cube root. So if we were in class, I'd ask you to guess what's going to happen. We start with the non-zero number. Guess what you're going to do? Well, you're not going to take the square root. You're going to take the cube root. What's the cube root of 8? What's a number that multiplies by itself 3 times and gives you 8? 2 times 2 is 4 times 2 is 8. Yeah, that works. It's 2. So we know the start of this is going to be 2. Okay, our number of zeros. We have 1, 2, 3, 4, 5, 6 zeros. So do you think we cut them in half like we did with our square root ones? Absolutely not. If it's a cube root, you're going to cut them in 3. So there was 6 zeros. We cut them in 3. You're going to be left with 2 zeros. There's your answer, 200. If that last one confused you, don't worry about it. As I said, it's not really a grade 9 topic. All right, let's go to the square roots of very small numbers. So in order to help us with this, again, let's start with generating a perfect square by multiplying something by itself. So we're going to multiply 1.2 times 1.2. So again, how do you do this? You go 2 times 2 is 4, and then 2 times 1 is 2. Don't worry about the decimal right now. Then you put down a 0, and now we're going to multiply 1 by everything. 1 times 2 is 2, and 1 times 1 is 1. Again, we add 4, 2 plus 2 is 4, and 1. Now, do you know where to put the decimal? A lot of people think it just slides straight down. That's actually not true. What happens is you count the number of numbers after the decimal. So there's 1 there, and there's 1 there, for a total of 2 numbers after the decimal. So there has to be 2 numbers after the decimal here as well. Well, in order for there to be 2 numbers after the decimal, you better put the decimal right there. Now you have 2 numbers after the decimal. So again, I want to ask, how could you do the opposite again? So if we were doing the square root of 1.44, we know what the answer would be, right? We're looking for a number that multiplies by itself to give this. Well, it has to be 1.2. So ignore the decimal for a second. Pretend it's just 144. What's the square root of 144? 12. So you can see how you get the 12. Now, where do you put the decimal? We had 2 numbers after the decimal here. Now we only have 1. Interesting. All right, before we do that, let's go to this question right here. Now, I'm not going to multiply this all out. I'll just tell you what the answer is. The answer is 0.000000009. Right? Use a calculator if you don't believe me. So again, can we use that to figure out how to do this? To figure out how to get the square root of this? We know the answer, right? What multiplies by itself to get this? It's that, 0.0003. All right, how do we get this? How do we get the 3 right here? Well, that's no problem. We just looked at the non-zero one, 9, and took the square root of that. Square root of 9 is 3. Okay, now what a lot of people think is you count the zeros, because we did that before with the big numbers. 1, 2, 3, 4, 5, 6, 7. Well, we can't do that. No. With the numbers, with the decimals, you count the numbers after the decimal. So you have to include the 9. 1, 2, 3, 4, 5, 6, 7, 8 numbers after the decimal. So in this one, we're going to have half as many. We should have 4 numbers after the decimal, and we do. All right, so here's your rules for this one. Take the square root of the non-zero numbers, and then the answer will have half as many decimal places, not zeros, decimal places as the radicand. So let's rip through some of these. The first thing we do is we ignore this. We just look at the non-zero part. So that's a 4. I know you can hardly see it now, but that's a 4 right there. So what is the square root of 4? The square root of 4 is 2. Okay. How many numbers are there after the decimal? Remember, we're including the 4. 1, 2, 3, 4. There's 4 numbers after the decimal. So how many numbers do we need to have in our answer here after the decimal? We need to have half as many. We need to have 2 numbers after the decimal. So don't do this. That's only 1 number after the decimal. We need 2 numbers after the decimal. So it's going to be 0.02, or if you want, 0.02. There's our 2 numbers after the decimal. That's half as many as the 4. We're done. Okay, next one. Take a look at the non-zeros. 121. Well, the square root of 121, not the easiest one. You know what it is? What multiplies by itself to give 121? 11. Now, how many numbers are there after the decimal, including the 121? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers after the decimal. So how many do we want after the decimal? We want 5. Well, we've already got 2, so how many zeros do I have to put in here? You have to put 3 zeros in there. Now you have 1, 2, 3, 4, 5 numbers after the decimal. That's half as many as 10. Perfect. Put a 0 in front if you want. I like always putting 0 point instead of just having point as my answer. All right, in this one here, we take a look at the non-zero number, and it's 9. Square root of 9 is 3. Then we look at the numbers after the decimal, including the 9, and it is 3. And we have to do half as many. Uh-oh, it's another one of these situations where we have to take half of 3, and you can't do it. So guess what you have to do? You need a calculator. You can't always do these ones either. All right, we take a look at the non-zero numbers. Well, the non-zero numbers are 225. So the first thing you're actually doing is taking the square root of 225. So what's a number that multiplies by itself to give 225? This is the biggest one that I would expect you to memorize. 15 times 15 is 225. So we can write down 15. Now, how many numbers do we have after the decimal point here? 2. So how many do we want in our answer? We want half as many. We only want 1 number after the decimal point. So don't put it here. That's 2 numbers after the decimal point. But if you put it right in the middle, you'll have 1 number after the decimal point, and that's your answer. Next one. So we look at the non-zero numbers, and you have 15. You got to take the square root of that. Square root of 15? There is no square root of 15. Guess what? Need a calculator. And the last one, again, the bonus one here for you. We've got a cube root. And I'm not pleased with this question. I'm going to change it to 64 so we can actually do it. Whoops. Okay, so we're going to start with the 64. And instead of taking the square root of that, I know there is a square root of 64, but we're not going to do that. We're going to do the cube root of 64. Do you know a number that multiplies by itself 3 times to get 64? 4 times 4 times 4 is 64. 4 times 4 is 16 times another 4 is 64. So we know it's going to be 4. Now, how many numbers do we have after the decimal? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't forget to include those 2 there, so we have 9. So, square root, we divide by 2. Guess what you're going to do in the cube root? Divide by 3. So how many numbers do you want after the decimal? You want to do 9 divided by 3 is 3. You want 3 numbers after the decimal. How are you going to do that? You're going to add in 2 zeros, and you now have 3 numbers after the decimal. Throw a 0 on front, and you're all done. Okay, hope that makes sense, and if not, let me know. See you later, everyone.